I'm a developer and a massive Formula One fan, so for the past few weeks I have been working on and off on a project that is going to help me become a better racing driver. You see, I love going to the karting track. Sure, I am no professional, but as a data nerd and a developer, I always wonder what my driving telemetry data might look like. I see it all the time when I'm watching Formula One, so why don't I try and build something for myself? I mean, how hard can it be? So here's the challenge. I want speed, throttle, braking and steering data so that I can plot it onto my own pit wall for go-karting. There is, however, one issue. We can't modify the go-kart because it's a rental. These things are like a few grand and I can't afford that. So all of the sensors, they need to be attached to me, which is either genius or a complete and absolute waste of my... So let's get to building. This little guy right here, this is the start of the madness. It's an IMU module. It measures movement and rotation using the onboard accelerometer and the gyroscope. This might be cool to look at, but it doesn't really tell you much. So let me show you a quick demo. Why did that hurt? Right. Make sure that's unplugged this time. So I've connected the IMU module to a Raspberry Pi, which is running a Python script to take the data from the module and then send it to my laptop here. So you can see that as I move it up and down now, you can see that we have the acceleration on the chart at the top there. And this is on each axis, so left, right, up, down, whatever. And then on the bottom, we have the rotation. So there we go, nicely plotted. Looks fantastic. So now I want you to imagine that this is attached to my foot. You see that on the rotation? That is a pedal press. That's the throttle or the braking being pressed. With some very simple maths, we can convert this into a percentage for how much the pedal is being pressed, all from rotation. Awesome. So using just that, I can measure how much a pedal is being pressed. So I'm going to go outside and test this while I sit in the car, but essentially, I have taken this off of the breadboard. The breadboard is now, or is now empty. And I've put it together using these jumper wires, which are different colors, but essentially this is the exact same setup. It's quite dark outside, so I wanted to show you what it looks like in the light here before I go outside. But essentially I've put the IMU sensor under my shoelace so that it's in a fixed point relative to my foot. So we should get maximum kind of accuracy. Press and stop. Press and stop. So that there is clear braking. That is clear that we are pushing the brake pedal. That means that this idea of foot rotation should work if we measure it finely enough. I was pretty happy with the results of this initial test. There was, however, a really big problem that I had completely overlooked. Okay, we have a problem. My initial idea was to run wires from each of the sensors that are placed around my body to a single controller in my pocket, for example. Which means that in the event of an accident, I might be thrown out of the go-kart, but my leg might stay in it. While this is a fun little experiment, I don't want to cause an accident where I lose a limb or I cause injury to another driver on the track. So cables are banned. Now, how am I going to solve this, eh? That is a very good question, Tom. How are you going to get data from one sensor to another without using cables? I've built version 2. These two boards, they look exactly the same, and that's because they are. Well, they pretty much are. The difference is the software that is on them. One transmits data and one receives it. Both are using Python and they communicate using a little Bluetooth chip that comes installed on the microcontroller. So now I'm just going to demo it so that you can see how these communicate and realistically what it looks like. So I've got the two sensors powered on. This one is connected to my laptop. This is the receiver, and this one is the transmitter. And even though there is a wire coming off of it, it is only connected to a power bank. So now these two are communicating, and if you don't believe me, I'm going to open up my real-time telemetry viewer. On the top, we have the acceleration being plotted of the receiver here. This is what will be in my pocket as I'm driving around the circuit. As you can see, it plots acceleration, right? This one is the transmitter. This one is going to be for the throttle or the brake, and this is going to be, you know, inside of my shoe. We can't have any wires going up my leg. And as you can see, as I rotate it, it plots onto the chart there. I can connect all of the sensors, I can send data to the receiver, no cables, no accidental amputations. This is fantastic. And the fantastic bit about this is that the accelerometer can also be used to track speed. Little issue with that one. It turns out that tracking speed using only wearables is very difficult. I could use a GPS, but my local go-karting track is indoors, so it's not going to be that accurate. I could set up beacons around the track and measure my distance from each of the beacons over a period of time, and therefore infer the speed that I'm traveling at. But the go-karting track will probably not like it if I show up putting random different bits of hardware in corners of the room. So we can't do speed. That's the bad news, but the good news is that IMUs with accelerometers allow us to do G-force. G-force is essentially the forces experienced by an object, in this case a go-kart, when it is in motion. So if a lot of G-force is being put onto the sensor, we know that the driver is either slowing down or speeding up. Think about the feeling you get when you put your foot down in your car while you're driving on the motorway. You're going from 30 miles an hour to 70 miles an hour, you experience a lot of force. Same with when you're braking, but when you slowly increase your speed, you won't experience that much force because it's steady. So G-force in this case allows us to measure exactly how aggressive or smooth my driving is at certain points around the track. If I turn a corner sharply at high speed, I will experience a lot of force pulling me this way. Whereas if I'm not at high speed or I turn gently, I will only experience a tiny amount of force. You see what I mean? So this is potentially more useful than speed in a go-karting environment. Not as interesting or exciting as the speed measurement, but I am doing the best with what I have. That is right, I am doing the best I can with what I have. And because I've been posting my progress of this project onto my social media channels for the past few weeks, I have had motorsport industry professionals get in touch with me. People that know this subject far better than I do. And they have said that this sensor isn't good enough. Why? Well, it is complicated, but essentially it boils down to the fact that this does not have something called onboard fusion. It sounds fancy, and I'm not going to go into too much about what it actually does, but essentially it means that without it, our data could start to become inaccurate at high speeds and the measurements could start to drift, which would completely ruin the data. So this is a big deal. In the first test I did where I sat in my car, you can actually see the sensor starting to drift when my foot is at a complete standstill. That right there would make the data unusable. So it's got to go. That was pretty edgy there. I've been recommended a few options and this is what I have settled on. It has a built-in accelerometer, a gyroscope and something called a magnetometer. The thing that sucks about implementing this new sensor into the project is that it doesn't really change anything in the video. Plug it in and that's it. Okay, that's not true. I do need to swap some of the Python code that's on the board that powers the old sensors library for the library that powers that sensor. But apart from that, no change is needed. Before I finish off this video, it is only right that we give it a proper test by driving around in a car. I've got it attached to my foot, the wireless one, although it is wired. It's only wired to a battery bank here, and so is my phone, but we'll ignore that. That's me operating it like a pedal. And then I have another one in here, which is for acceleration, the accelerometer. That's the top one right here. So we're going to drive around and fingers crossed it has the desired effect. Okay, you are probably wondering why I'm not sat in the driver's seat. Full transparency, I thought it would be a really bad idea for me to test this on a public road with cables everywhere down by my ankles and then upload it to a video on YouTube as video evidence of me driving potentially in an unsafe manner. I mean, that really would be stupid. So I've asked my girlfriend to drive for me while I film with the sensors attached to my feet as a passenger, and then I'll just move my feet as if I'm the one driving. Ultimately, the point of this test is to make sure that the accelerometer actually detects the movement of the car when I'm also pressing the pedals. So if we fake press the pedal, it's exactly the same really. As we start to move around, very slightly, we should see changes in the accelerometer, which shows the G-force right? So for example, I'm gonna ask rear to speed up in 3, 2, 1, go. And so I've just mimicked that with my foot, and you can see where it sped up and where it slowed down. One more, go, 3, 2, 1. So it's weird me trying to get my foot lined up at the same time, or in sync, because we're basically faking it. But the accelerometer works and the pedal works, which is the main thing, so sweet. So far, that is all of the progress that I have made with this project, and there are a few things that we need to do before it can be used on a real go-kart track. Things like adding data storage and smaller batteries so that I don't have to carry around this massive, where is it? This massive battery bank. Oh, and we also need to look at creating some kind of housing for these components so that they are not loosely inside of my shoes or in my pockets, because that's unsafe and probably a bit uncomfortable as well. But then we will be able to take it to the track, and I cannot wait to do that. But I'm going to save that for another video. See ya.